everyone. I'm Mansi Mahindru from ABES Engineering College, Ghaziabad. Now, in this particular video, we're going to start with another topic or another application of greedy algorithm, that is Huffman coding and task scheduling. So let's start with the video. So first of all, we're going to start with task scheduling problem. And from this particular topic, question can be asked for 5 marks in your university exams. So first of all, let's understand what this problem is. Task scheduling problem says that if you are given some n number of tasks for the day, and with each task you are given deadline, means in which you have to complete that task, and along with the deadline there is one more parameter, that is penalty. It is also given to you with every set of tasks. So the problem says that if you will fail to meet the deadline of any task, you have to pay that penalty. So your goal is, you have to plan your schedule in such a way that the minimum penalty you have to pay at last. This is your main agenda of this particular problem. So this is a minimization kind of problem where you have to reduce your penalty. Means, as it is written, that this is one very interesting problem that are uh, going to that we can solve using metroids in the problem of optimally scheduling unit time task. As we know that we have already studied operating system in our second year, so there we have seen that there is one processor and we have n number of tasks that we want that processor should do, and our task is that the idle time of that particular processor should be minimum. We don't want that the processor should sit idle even for 1 second. So similarly, we are given n number of tasks here, and along with the task, we are given the deadline and penalty. So we have to ensure that we should perform all the tasks before the deadline. Otherwise, we have to pay the penalty, and we have to minimize that amount uh, in the answer. That is our main task. So let's start with the problem. This is very interesting problem. So in this particular question, you will going to get, let me take my pen. So in this particular problem, you're going to get some task. As you can see here, some amount of task you're going to get in the question. Along with the task, you will also get the deadline, means by which date or by which time you have to wind up this task. That particular amount or that particular value will also be given in the question. And after that, one penalty is also given to you. If you will fail to meet that deadline, then you have to pay the penalty at last. This is the overall problem scenario. So let's start with the question, then everything will be clear to you. So as you can see here, it is saying that you have to find the optimal schedule for the following table, where the task with the penalties or weight are deadline and deadline are given to you. So as you can see here, we are given total 7 tasks, out of which we have to schedule that which task is to be done first, after that which task is to be done on during second iteration, and so on so forth. And for each task we are given the deadline and the penalty. So let's start with the question. And when we used to discuss this question in the class, now we ask students like what approach is coming into your mind. So students used to say that, ma'am, the first approach that we can apply in this particular question is that sort the task with respect to deadline in ascending order. Means they used to say we should arrange our task as per deadline in ascending order. Means the task whose deadline is Monday. For example, your faculties have given you some assignments, and one faculty has asked or has set the deadline as Monday. Another faculty has asked for Tuesday, then Wednesday, Thursday, Friday, and so on and so forth. So as per the student's state of mind, they used to say, ma'am, the faculty who is asking for the assignment on Monday, we should wind up that assignment first. After that, the faculty who's asking assignment for the Tuesday, then will complete that assignment and so on and so forth. So similar approach we're going to apply here, and we'll try to find out whether the penalty that we are getting at last is minimal one or not. So let's start with the question. So as you can see, so first, if this question will be asked in your university exam, then you can take help of one Gantt chart. So maximum deadline task in this particular question is 6. So you have to make one Gantt chart here: 0, 1, 2, 3, 4, 5, 6. Right? So you have to set this value as per the highest deadline task. After that, what you will do? You have to arrange your task with respect to deadline in ascending order. So if I'll arrange it, then the first task that I can solve is A5, right? So A5 deadline is 1. So means I can schedule it here. Means this A5 task need to be performed here. After this, next task that I have to do is A2. A2 is 2 now. After 1, next value is 2. We have arranged it in ascending order. So for if you will get this question, you have to draw this particular matrix again in which your deadline should be sorted in ascending order. But here we are not doing that. We are doing it randomly. Manually, we are arranging it. So after 1, we'll get A2. A2 deadline is 2. So we have to do this task here. Okay. After that, we have 3, A4. So A4 deadline is this. Done. Next is A, next 3, we have 4. See, we have 2 4s. Means 2 tasks has same deadline, 4, and this has also 4. Oh, this has also 4. So now, which task you're going to perform? So if I'll go with stable sorting, I should go with first one. The value which is first in my input, it should be first in my output as well. So let's try this approach. We'll take this value. We'll take A1. So A1 deadline is 4, so we'll do that. A1. Next we have is again 4. So this particular task needs to be done at fourth day, but that fourth day has already closed, so it means we have to skip this assignment. We have to skip this assignment also. And next after 4, we have only this particular task left. So its deadline is 6, but there is no more task. So why should we waste our first day? So we're going to schedule A7 here. So with this particular approach, total penalty that we have to pay is equals to, we have skipped 2 tasks, na? This one and this one. So its total penalty we have paid is 50 plus 20 is 70. It's 70. Total penalty we have paid. So can we reduce this penalty by applying some other approach? If we will try to reduce this penalty, is there any other task? So when we ask this thing with students, so the next reply they used to give us is, ma'am, just arrange with respect to penalty. Means the task which cost us more penalty should be done first. Means what we will do now, let's take different pen. 1 second, let me take pen. So my second approach will be sort my penalty with respect, sort my penalty in descending order. This can be one approach. So again, I will draw the Gantt chart: 0, 1, 2, 3, 4, 5, 6. Let's try to find out whether this particular approach will solve our problem or not. So in descending order, na, so the highest penalty task is it's 70. It's already sorted in decreasing order, so it will be very easy for us to do. So again, the first task is 70. So we can select this task. As you can see, the deadline is 4. Deadline is 4, so we can do this task. If this particular faculty is asking on fourth day, then we can submit this assignment on first day also. But we don't know na whether in this for subsequent question आगे जाने के बाद we can find some task whose deadline is 1. Then how we're going to schedule that particular task? In that case, we have to leave that task. So what we'll do, we're going to schedule in the max day, means we're going to solve that assignment in worst case. So its deadline is 4 now. So we're going to submit this assignment on 4th day only. Might be possible na some other faculty mood will get changed and they'll give you assignment to be submitted on first day. So you will write here A1. A1 will be uh, submitted on 4th day. Next is 60. Its deadline is 2, so we'll submit it here only. A2 will be submitted here. Next is A3. A3's deadline is again 4. You can see again 4. So at this time we should take it, but 4th day we are delivering one assignment, so we can schedule it here, no? हम इसको यहाँ schedule कर लेते हैं. We don't have to skip this. Next, this is 3. Its deadline is 3, but on 3rd day we are already giving one assignment, so we'll schedule it 1 day prior. But on 1 day prior also we are delivering one assignment. So 1 day prior, yes, this day is empty, so we'll schedule this particular assignment here. So it will be A4. So this is A4. Next, this is 1. Its deadline is 1, but first day is already occupied by A4 assignments, so we have to leave it. Next, 4. No, we have to leave it. Next, 6. Yeah, we can do this assignment. A7. Yeah. So the total assignment that we have left is 30 plus 2 assignments we have left. And so total penalty with this approach is 30 plus 20, that is equivalent to 50. So as you can see here, that this particular approach is giving us more optimal result. So in your exam, if you get this particular question, you have to try both of these approaches, and you are going to get the optimal result with the second one, but you have to show both in your university exam if this question will come for 10 marks, right? Now, this is all about the task scheduling problem. And this particular problem will take n log n time, because as we have seen that we are doing sorting in every approach. A particular sorting will take n log n. And after that, we are iterating all the tasks one by one. And it will take O of n log n plus O of n, which is equivalent to O of n log n time complexity. So this is all about the task scheduling problem. And the next problem that we're going to start in this particular video is Huffman coding. So we all know that Huffman coding is basically a data compression technique which will help you to encrypt your data from unauthorized parties. So it's a data compression technique, and Huffman coding ensures you that it will going to compress your data 99%. To 99% it will going to compress your data. So how we have to perform Huffman coding if this particular question will be asked in your exam. Uh, as it is written before going to numerical, let's read these particular points. These are very important for Huffman coding. So Huffman coding is a famous greedy algorithm. It is for lossless compression of data, means our data should not be lost. It should not be with any unauthorized party. So we have to compress it. And when we'll apply this Huffman coding, that particular data will not get lost. It is a variable length coding. Yeah, it's a variable length coding. Next, it assigns the variable length code to all the characters. The code length of the character depends on how frequently the alphabet is occurring in the text. Then the character which occurs more frequently gets the smallest code, and the character which occurs least frequently will get the largest code. And it is also known as Huffman encoding. This is all about the Huffman coding theory. If you'll get the 2 marks question, and then this is more than enough to write. Now let's understand how to solve the question if it will come in your university exam. So related to this subject, Huffman coding numerical will be coming directly. The numerical will be coming in your exam, and in the numerical they'll going to ask you max to max, they'll ask these three things in the question. As you can see, when let's start with the numerical. So here, let me take my pen. Yeah. So here it is written that the file contains the following characters. See, these all characters. The file contains the following characters with the frequencies as shown. If Huffman coding is used for data compression, then you have to determine these three values in the question. The first value is Huffman code for each character, B, average code length, and C, length of the Huffman encoded message in bits. These three things you have to answer from this particular question. So now let's start with the question. First of all, it is saying that you have to uh, find out the Huffman code, means the encrypted code for each data. So let's start with the question. So this particular data is given to you. And firstly, what we'll do, we're going to arrange all our data in ascending order. So step one, as you can see here, the smallest occurring alphabet is T. So we have arranged it at first place. Then after that, 3, O. Then it should be U. Then next one is A. Next is I. Next, then S. And then so first step is you have to arrange all your alphabets as per their frequency in ascending order. Once you have arranged it, then you can start building your Huffman tree. So what you will do in the step number two, step one, number one, may you have to arrange all data in ascending order with respect to frequencies. Yeah. In the first step, you have to do this thing. And after that, after this particular step, you have to start building your Huffman tree by merging nodes in ascending order. So as you can see here, in this particular step only, we are having these two values first. So we're going to merge these two values in the second step. So 1 plus 3 is the total of these two will be at the root. So you'll write it like 4, and T's frequency is 1 and O's frequency is 3. Now again you have to sort. Now you can see here, after sorting, means while doing sorting, we got two 4s. But you have to apply stable sorting here. So when will you apply stable sorting, the value that is given first in the input will be first in the output as well. So your 4 will remain here only. And after that, in the next step, what you will do, you'll merge these three. So that will become 8. And this will be like this. You can see in the next step. As you can see here, we have done this. After that, again, sort the values, but it is already sorted. So what will be done? Again, 10 plus 8, it is 18, and this will be merged. As you can see here, we have done the same thing here also. Again, we're going to sort. But now when we're going to sort, the 18 should be ideally, it should be ideally after 15. Means this particular 18 should be this 8, this 10, and this 4, this 4, 1, and this is 3. This should be here and this should not be here. So again, what you will do, you will going to merge it. This will become 22 and this will be like this. So you can see this in the next step. I have done this. See, you have done this, right? Again, you will going to sort, and in the sorting, you will going to merge 15 and 18. Means after sorting, it will be like this, and then you will be having this particular thing, and at last you're going to merge 25 with 33, and the final tree that you will going to get for this particular question is this. This is your final tree. This is your final tree that you are going to get at last. Now, let's move to the question. Now, the first question that they have asked us is you have to return the final variable length codes for each alphabet. So, what you have to do, you have to mark all the edges either by 0 or either by 1. So, what you will do, all the left edges will be marked 0 and right edges will be marked 1. Left edge 0, right edge 1. Left edge 0, right edge 1. 0, 1, 0, 1, 0, 1. Now you can easily find the code for each alphabet. Like if we'll start with I, if we'll start with I code will be start from root to leaf. I is here, na? So 0, 0. So the code will be 0, 0. Next, S. S code will be 0, 1. Next is E. E's code. E's code will be E. Just check the path. E is here, na? So the path will be this and this. So it will be 1, 0. Likewise, you have to calculate for every. As you can see here, I have already calculated Huffman code for each alphabet. You can cross check it. For example, if I'll calculate for T, the code will be 1, 1. See the path. The path 1, 1, 0, 0, 0. So T is 11000. Likewise, you have to calculate the Huffman code for each character. Now, the next thing it has asked is you have to tell us the average code length. Average code length means, like you will see here, average code length is nothing. It's simply like this. You have to calculate it like this only. Um, Means, for example, if I'll calculate the average code length, so A is occurring for 10 times in the message. And for each and every time we are encrypting it in 3 bits. So 10 into 3, 3 plus. It is occurring for 15th time. And every time we are encrypting in 2 bits, so 15 into 2. Likewise, you have to do. As you can see here, I have done the same thing here. And after that, you will get 2.52. Average length code will be 2.52. Next, you have to tell how many characters, means how many bits at last will get transferred to the receiver's end. So the simple formula for that particular thing is this is your average length and this is your 58. 58 is nothing, it's the sum of all these alphabets. When you will do the sum 10 plus 15 plus 12 plus 3 plus 4 plus 13 plus 1, you will get 58. So 58 into 2.52 is 146.16, which is nearly equal to 147 bits. So total bits you have to transfer for this particular message will be equal to 147. So this is all about the Huffman coding. If you get the question, you can easily solve it. And max to max, they'll ask you these 3 things and you can easily answer this thing. So these are the references. Thank you for patient listening. Do subscribe CETL channel. Follow for more videos. Thank you.